Hi from Tokyo, Japan, and welcome to Jeremy's IT Lab. In this video, we're going to cover a topic that's a recent addition to the CCNA exam, AI and machine learning. Ever since ChatGPT was publicly released in 2022, AI seems to be on everyone's mind. So what is AI, what is machine learning, and what do they have to do with networking? We'll answer those questions and more in this video. But before we get started, let me take a minute to shill my books, Acing the CCNA Exam Volumes 1 and 2. I always recommend studying from multiple resources, and my books are great in combination with this course that you're watching now. AI and machine learning, the topics of this video, are covered in Chapter 22 of Volume 2. You can get the books from Amazon or directly from the publisher using the links on the screen right now. Use code AU35MCD to get 35% off either volume, or you can get 50% off if you buy both together. Now let's get started. So what are we going to cover in this video? First, I'll define AI and machine learning. What are they? How are they related? Etc. Then we'll examine some different types of machine learning: supervised learning, unsupervised learning, reinforcement learning, and deep learning. We'll cover how each of these learning methods works, as well as their advantages and disadvantages. Then we'll move on to predictive and generative AI, as well as their current and potential applications to networking. Finally, we'll cover some specific AI features of Cisco's Catalyst Center. Since the CCNA is a Cisco exam, it's always good to be familiar with Cisco's own solutions. So that's what's on the menu for today. Now let's move on to define AI and machine learning. So what is AI? Artificial intelligence, usually called AI, uses computers to simulate intelligence, allowing them to exhibit behaviors typically associated with humans, such as recognizing patterns, learning, making decisions, and solving problems. These days, AI models like ChatGPT are on everyone's mind, but the field of AI is much wider and older. Let's look at just a few examples of AIs, many of which you're probably familiar with. Virtual assistants like Siri, Alexa, and Google Assistant all use AI. They help you perform tasks like setting reminders, answering questions, or controlling smart home devices by processing your voice commands and providing relevant responses. Recommendation systems, like those on Netflix, YouTube, or Amazon, use AI to analyze your preferences and suggest content or products tailored to your tastes. Just as you might recommend a show, video, or product to a friend based on what you know about them, these AIs perform a similar role on a much larger scale. By learning from your viewing, searching, and purchasing habits, they continuously refine their recommendations to offer suggestions they think you'll enjoy. Self-driving cars and robotics, such as Tesla's full self-driving and Waymo, rely on AI to process sensor data, make real-time decisions, and navigate complex environments. Chatbots, like ChatGPT, can generate human-like text for tasks ranging from customer support to creative writing. That logo on the right is the chatbot that appears when you visit Cisco.com, for example. That kind of chatbot is also known as a virtual concierge. AI is also behind advanced game-playing systems like Stockfish in chess or AlphaGo in Go, which have long surpassed the abilities of even the best human players of these games. And of course, there are many more examples. The point is that AI is a very wide field with countless applications. And AI is only growing in importance thanks to an increase in computing power, the availability of big data, and breakthroughs in AI research, such as the AI boom since ChatGPT's release. Next, let's dive deeper to examine machine learning. Machine learning, or ML, is a subset of artificial intelligence that focuses on enabling computers to learn from data and improve their performance over time without needing explicit programming. Instead of relying on hard-coded instructions from a human, machine learning algorithms identify patterns in data and use those patterns to make predictions or decisions. To put it in context, this blue box represents the field of AI, and ML is a subset of that field. Not all AI uses machine learning, but it's one of the most impactful components of modern AI. So how does machine learning work? Let's break it down. At a very high level, it can be broken down into three parts. This represents the system or model that we want to train with machine learning. The learning starts with input data. This could be anything from numbers in a spreadsheet to images, videos, or text. That data is used to train a model, meaning the machine learning algorithm processes the data to learn patterns or relationships within it. Once trained, the model can use what it has learned to make predictions or decisions when new data is provided. This cycle, learning from data and applying what's learned, is what makes ML so powerful. Machine learning powers many AI applications you already use, including those listed in the previous slide. For example, email spam filtering uses machine learning to identify unwanted messages. Personalized product recommendations learn from your previous behavior to help you find items you'll probably want to buy. Fraud detection in banking uses previous data to identify and prevent suspicious activity. It's also behind advanced techniques in natural language processing, which enables computers to process and understand human language. And of course, there are plenty more examples. Although, as I said, not all AI uses machine learning, it is the driving force behind many modern AI applications. AI as sophisticated as ChatGPT, for example, wouldn't be possible without machine learning. Now that we know the basics of machine learning, let's look at the four main types. First, supervised learning. This is where the model is trained on labeled data, meaning the correct answers are provided during training. The model uses this data to learn and make predictions or classifications on new data. Next, unsupervised learning. In this type, the model is given unlabeled data, and its goal is to find patterns, relationships, or groupings within the data. It's a more hands-off approach. Then we have reinforcement learning. Here, the model learns by interacting with an environment, receiving rewards or penalties based on its actions, and continuously improving to maximize its performance. For example, this type of learning is used to train AI in game-playing systems like AlphaGo, or in self-driving cars, where the AI learns to navigate by trial and error. Finally, there is deep learning. Deep learning is a specialized subset of machine learning that uses artificial neural networks to handle large data sets and perform complex tasks. It's inspired by the way the human brain, a natural neural network, processes information. Once again, AI is a broad field, and machine learning is a subset of AI that drives the most powerful AIs that exist today, from large language models to image recognition. Then, supervised, unsupervised, reinforcement, and deep learning are subsets of machine learning. We'll take a look at each of these learning methods in the following slides, but keep in mind that these aren't the only types of machine learning. They're just a few of the most prominent examples, and they aren't always exclusive. They can be combined according to the needs of the particular application. For example, deep learning neural networks can be trained using any of the other three methods. Okay, now let's look deeper into each of these four types. We'll start with supervised learning, which trains the model on a labeled dataset. This means that each input provided to the model for training has a corresponding label. By examining these labeled examples, the model learns the relationship between the data and its given labels, building its understanding during the training phase. For a simple example, let's say we want to train the model to differentiate between photos of cats and photos of dogs. We start with a set of labeled training data, meaning each photo is labeled as either cat or dog. To train an AI, you should have more than 8 photos, of course, but I'm just demonstrating the concept here. So you feed the labeled data into the model, and it should, with enough data, build an understanding of what a cat looks like, and what a dog looks like. Once the model has been trained, if you feed it an unlabeled photo of a dog, it should be able to identify it as a dog, and it should be able to do the same for a photo of a cat too. By training on labeled examples, the model learns to classify new, unseen data with high accuracy. So what are the main advantages and disadvantages of this method of machine learning? Well, if labeled data is available, supervised learning is highly accurate. When training the model, it's not going to misinterpret a cat as a dog, because the cat is already labeled as a cat. But it requires large labeled datasets, which can be expensive and time-consuming to create. As I said before, you're going to need a lot more than 8 photos to create an accurate model. Another advantage is that it's straightforward to understand and implement. The data is already labeled, so you just need to train the model with as much data as possible, and it should develop a good understanding of each label's characteristics. And one more disadvantage is that the output is limited to the labels in the training data. For example, if you train the model only to classify cats and dogs, it won't be able to recognize or classify a photo of a bird. This means supervised learning isn't ideal for tasks requiring flexibility or identifying entirely new categories. Let's move on to unsupervised learning, which trains the model on an unlabeled dataset. This means that no predefined labels are provided. Instead of being told what each data point represents, the model analyzes the data to discover patterns, structures, or relationships on its own. It can then group similar data points into clusters based on shared features. Let's use the same example as before, feeding the model photos of cats and dogs. In unsupervised learning, we feed the model unlabeled training data, so the images are provided without identifying them as cat or dog. The model processes the data and looks for patterns or similarities among the images. Based on its analysis, it groups the images into clusters. Here, it has identified that the cat images all share similar features, grouping them into cluster 1. The dog photos, sharing their own set of features, are grouped into cluster 2. It doesn't know what these clusters represent. It simply groups similar images together based on features like fur texture, shape, or color patterns. A human can then interpret these clusters and label cluster 1 as cat and cluster 2 as dog. Then, if you feed the model another image of a dog, it should be able to recognize that it has similar features to the other photos in cluster 2 and assign it to that cluster. And same if you feed it another photo of a cat. And if you feed it a photo that's neither a cat nor a dog, like this bird, it recognizes that it doesn't fit into either cluster and creates a new one. And a human can once again label that new cluster. So what are the advantages and disadvantages of unsupervised learning? One big advantage is that there's no need for labeled data, so that saves a lot of time and cost in labeling huge data sets. But interpretation and labeling of the results by a human is still required to make sense of the results. Another benefit is that unsupervised learning can reveal hidden patterns or structures in data that might not be obvious to a human. For instance, it might group customers based on purchasing behavior, even if no explicit labels exist. Because the data isn't pre-labeled, the model is free to group the data according to what it notices, not according to the strict labels used in supervised learning. But without labeled data, the model's accuracy might be lower than supervised learning for specific tasks. Unsupervised learning is a powerful tool for discovering patterns and relationships, especially when labeled data isn't available, but it requires human input to interpret results and might not always match the precision of supervised learning. Next, let's talk about reinforcement learning. Reinforcement learning trains a model by rewarding or penalizing its actions in a given environment to maximize its performance over time. The model learns to take actions within its environment that achieve the highest reward or best outcome. So how does it work? First, the model, which is called an agent, interacts with an environment. It takes an action and receives feedback, which could either be a reward for a positive action or a penalty for a negative one. For example, if the AI is learning to play a game, actions that lead toward victory would be rewarded, and actions that lead toward defeat will be penalized. The agent uses this feedback to adjust its behavior and learn which actions lead to the best results. And the cycle repeats, allowing the model to improve its ability to take the correct actions over time. Let's consider some examples of reinforcement learning in action. In self-driving cars, the agent learns how to navigate safely by trial and error, earning rewards for avoiding obstacles or staying in the lane. In game AI, reinforcement learning is used to master strategies in games like chess, Go, or video games, where the agent learns by playing and improving over time. And in robotics, agents can be trained to perform complex tasks like walking, picking up objects, or assembling items through reinforcement. Like the other learning methods we covered, let's consider a couple advantages and disadvantages. It's capable of learning complex behaviors that are difficult to program manually. By allowing the model to interact with the environment on its own, it can learn these complex behaviors without manual coding. But it can be quite resource intensive, requiring significant time and computational power, especially for complex environments. The model has to spend a lot of time and resources interacting with the environment. Another advantage is that it adapts well to dynamic environments, making it useful for tasks where conditions are constantly changing. Through reinforcement, the model can adapt automatically to changes. But if the reward system isn't carefully designed, the agent might focus on short-term rewards rather than the best long-term outcome. So the system of rewards and penalties needs careful planning and design to avoid suboptimal learning. An interesting example of reinforcement learning is MAR.io, a program created by Seth Bling and shown in a YouTube video. MAR.io uses reinforcement learning to teach itself how to play a level of Super Mario World. It receives rewards for progressing through the level, and over many evolutionary generations, builds a model that can quickly and effectively navigate the level. MAR.io is not only an example of reinforcement learning, it also applies the principles of deep learning, which we'll cover next. Deep learning is a subset of machine learning that uses artificial neural networks to process and learn from large and complex datasets. An artificial neural network is a computational model inspired by how biological neural networks, like the human brain, process information. Data is passed through multiple layers of interconnected nodes, like the neurons in the human brain, with each layer extracting increasingly abstract features. These layers are what make deep learning so powerful. Note that deep learning isn't entirely separate from the other methods we've looked at. Neural networks used in deep learning can be trained using supervised, unsupervised, or reinforcement methods. So it's essentially a more advanced way of applying these approaches to solve complex problems. A deep learning model consists of an input layer, which receives inputs like images. Then there are several hidden layers. I've shown 3 here, but there could be thousands in some models. And then there is an output layer. And these layers are connected by a complex web of connections, processing data from the input layer and resulting in outputs in the output layer. For example, if the purpose of the model is image recognition, if you feed it an image of a cat, the result in the output layer should be cat. If you want to learn how deep learning really works, I recommend watching the Neural Networks playlist by 3 Blue 1 Brown on YouTube. It covers much more than you need to know for the CCNA exam, but is a great primer on how deep learning and neural networks work. So what are the advantages and disadvantages of deep learning? First of all, it excels at handling large, unstructured datasets like images, audio, and text. Data that doesn't have a clear, predefined structure. It doesn't fit into traditional rows and columns of a database or spreadsheet. When it comes to tasks like image recognition, natural language processing, and autonomous driving, deep learning provides state-of-the-art performance. But it can be quite resource-intensive, requiring significant computational power and large datasets for training. And it's often referred to as a black box, because the hidden layers make it hard to interpret how the model arrives at its decisions. For instance, while the model might identify a cat accurately, it's difficult to pinpoint which specific features it used to come to that conclusion. But regardless of any drawbacks, deep learning is one of the most powerful tools in artificial intelligence. Looking back again at MAR.io, notice the neural network that it has built to navigate through this stage of the game. While I showed MAR.io as an example of reinforcement learning, it uses reinforcement to train an artificial neural network, although deep learning models typically use many more layers than this. So those are the main types of machine learning we'll cover in this video: supervised, unsupervised, reinforcement, and deep learning. As I mentioned before, these aren't the only types of machine learning, and models can use combinations of these methods. For example, deep learning models can be trained using supervised, unsupervised, or reinforcement learning techniques. There's also semi-supervised learning, which combines labeled and unlabeled data, enjoying the benefits of both methods. But these 4 types are what I recommend knowing for the CCNA exam. Now let's move on to predictive and generative AI, 2 key applications of AI that take advantage of machine learning and especially deep learning. Before we dive into each, let's briefly define them. Predictive AI uses machine learning to analyze historical data and predict future outcomes or trends. A couple of examples are security anomaly detection in a network or weather forecasting. And generative AI uses machine learning to learn patterns from existing data and create new content, such as text, images, or audio. Some well-known examples are ChatGPT and Gemini for text generation, or Midjourney and DALL-E for image generation. This diagram shows where predictive and generative AI fit within the fields of AI, machine learning, and deep learning. While the most powerful predictive and generative AIs today rely on deep learning, simpler AIs can also exist outside deep learning, using other machine learning methods. Now let's look a bit deeper into predictive AI. Predictive AI analyzes historical data to forecast future outcomes, trends, or events. It identifies patterns and correlations in past data, and applies those learned patterns to make predictions about new or future data. Predictive AI is very widely used for a variety of applications. Let's list a few. In healthcare, it can predict patient outcomes or the progression of diseases, helping doctors make better treatment decisions. For example, AI can analyze an X-ray to identify diseases earlier than a doctor might in many cases. In network security, it's used to detect anomalies that might indicate potential threats or failures. It's also used in traffic management, where it can predict congestion based on both historical and real-time traffic data. I'm referring to road traffic here, but predictive AI can play the same role for network traffic, predicting congestion or potential bottlenecks based on usage patterns. Businesses rely on predictive AI for forecasting sales trends or understanding customer behavior, and meteorologists use it for weather forecasting, analyzing data to predict future conditions. Okay, those are just a few examples of predictive AI. Now let's consider its advantages and disadvantages. It improves decision-making by providing actionable insights, enabling you to detect potential problems before they occur, such as network issues or severe weather. But to do so, it requires high-quality and relevant historical data to be accurate. Without significant amounts of high-quality data, the AI isn't likely to make accurate predictions. And its performance depends on how well the patterns in past data generalize to new scenarios. If the future is significantly different from the past, the model may struggle to make accurate predictions. Now let's look at generative AI, which is quite popular these days for a variety of uses. Generative AI learns patterns from existing data and creates new content, such as text, images, and audio. It focuses on producing outputs that resemble the input it was trained on, but are entirely new creations. For example, let's say we train a generative AI model on labeled data of cats and dogs. This model learns the features of these animals. Then, if we give it a prompt like generate an image of a cat, the AI uses its understanding of patterns in cat images to create an entirely new picture of a cat that didn't exist before. So let's consider some applications of generative AI. In text generation, tools like ChatGPT, Gemini, and Copilot can generate human-like text for tasks such as answering questions, writing code, or writing emails. These are called large language models, LLMs. For image generation, AIs like Midjourney and DALL-E create detailed artwork from text prompts, like the diagram above. And in video generation, tools like OpenAI's Sora and Google's VO2 can generate realistic videos based on user input. Now let's look at its advantages and disadvantages. First of all, it's great for creative tasks where human input is limited or time-consuming. For example, a generative AI chatbot can take over a lot of online customer service from humans, only escalating to a human when necessary. Generative AI enables the automation of content creation across various fields, but this, of course, has its downsides. There is a major risk of misuse, such as deepfakes and plagiarism. There's also the problem that generated content is only as good as the quality of the training material, as well as the model itself. Let's be honest, there's a lot of AI slop out there. I've even seen an entirely AI-generated CCNA course. Fortunately for me, AI isn't ready to take my job just yet, but that could very well change in the future. And since I mentioned the material used to train these AIs, there are serious copyright issues regarding these models, both in the data used to train them and in the outputs they generate. Finally, one more thing worth mentioning is the problem of hallucinations, basically making up answers that are totally incorrect. This is the main reason why I recommend avoiding large language models like ChatGPT when you're studying for the CCNA. It just isn't reliable enough. But regardless, generative AI is clearly a very effective tool that many of us use daily for various tasks, and it will only get better from here. So far in this video, we've looked at AI and machine learning from a more general perspective. But let's move on to consider some applications of predictive and generative AI to networking. First, here are a few ways that predictive AI can be applied to networking. Traffic forecasting is one application. By analyzing past traffic patterns, AI can predict future patterns, providing insights into how to optimize bandwidth allocation and prevent congestion. For example, the AI could advise you to increase the bandwidth of a particular link with Ether channel, or optimize the QoS policy to allow important traffic to get through without delay. Security threat detection is another important application. If the AI notices anomalies, it can predict that an attack is occurring or about to occur, helping to minimize the damage. It can also be applied to what's called predictive maintenance. By anticipating hardware failures in advance, you can proactively replace faulty hardware before it causes a major issue. And what about generative AI? It has several uses, and I'll demonstrate a few ways you can use ChatGPT for some of these applications as well. First, you can use generative AI for documentation. For example, by providing information about your network and its configurations, the AI can automatically generate documentation for your network. Or you can use AI to help with generating the configurations themselves, based on the policies and requirements you provide. For example, in this clip, I provide a simple network diagram to ChatGPT and ask it to generate configurations that enable full connectivity in the network. The generated configurations can then be copied and pasted into the devices, after verifying that they're correct, of course. Another application is network design. Generative AI can suggest designs tailored to your specific needs, offering advice and optimizations. Troubleshooting is another useful application. You can provide log files or error messages and get help in the troubleshooting process. For example, in this clip, I share a log message with ChatGPT, and it outlines the cause of the message, as well as steps to fix the issue. You should always verify what ChatGPT says. Don't follow it blindly, but it can be very helpful in the troubleshooting process. And the last use case I'll mention for now is script generation. You can use AI to automatically generate network automation scripts, such as Python scripts to configure network devices. In other words, you can automate your automation. In this clip, I do just that, asking ChatGPT to generate a script to configure a router. Let me repeat myself. Always double-check before using anything ChatGPT gives you in a real network, as it can hallucinate and make mistakes. But there's no doubt that it has many very useful applications to networking. Finally, let's cover some features of Cisco Catalyst Center that leverage AI. Although the exam topics list doesn't say you need to know these AI features for the exam, it's good to have a general idea of how Catalyst Center uses AI. So, Catalyst Center, which used to be called DNA Center, features a variety of AI-enabled features to identify issues before they impact users, reduce the time required to resolve issues, and increase the performance and security of the network. I'll list some of the features, and then show what some of them look like in Catalyst Center's GUI. But if you want a more detailed look, you can check out this video from Cisco, Discovering the Secrets of AI and ML in Cisco Catalyst Center. I made this short link that will redirect you to it, jitl.jp/cat-AI, or you can just Google the title to find it. You don't have to know everything covered in this video for the CCNA, but check it out if you're interested. So what are some of those AI features in Catalyst Center? One is AI Network Analytics, which is actually an umbrella term that includes several other features within it. Basically, it's all about using AI, specifically machine learning, to establish the baseline behavior of the network. In other words, it determines what is considered normal for this network. It can then provide insights and recommendations for optimizing the network, and monitor to predict and detect anomalies, things outside of the baseline. Here's a screenshot showing one small part of AI network analytics. As the legend here shows, green indicates the predicted value, or rather range of values, which is the baseline that has been established. And blue shows the actual value, in this case the amount of time it took hosts to lease an address with DHCP. And the bottom two graphs show the same thing for authentication and association times. This data here is about Wi-Fi connections, but AI network analytics is not limited to Wi-Fi, of course. And now let's continue with the Machine Reasoning Engine, MRE, which uses AI to perform root cause analysis when network issues arise. It can then suggest resolutions or take automated corrective actions to fix the issue. So this reduces downtime by identifying and resolving issues faster than traditional methods. Traditional methods might be something like a user complains about a network issue, you investigate and try to identify the issue, make some sort of change to remedy it, and then hope it solves the problem. MRE can potentially automate that entire process. Here's a quick look at MRE in action. MRE identified an issue, an interface that is down. Here, you can see its reasoning process, the root cause analysis that it performs to identify what caused the issue. And you can see more details here. Now, I don't have access to Catalyst Center with MRE in my lab, so I got this screenshot from this presentation from Cisco, by the way. If you want to know more about Catalyst Center, Cisco has plenty of documentation and video demos, so they're worth checking out. Okay, next we have AI Endpoint Analytics. As the name suggests, this focuses on endpoints, the devices connected to the network. AI Endpoint Analytics identifies and classifies devices on the network, providing detailed visibility into those devices and what they're doing on the network. It detects unauthorized devices or unusual behavior, for example, identifying devices engaged in malicious behavior on the network. And it simplifies device onboarding by automating profiling and segmentation. What that means is when a device connects to the network, Catalyst Center can identify what kind of device it is and apply appropriate security policies. This enhances security and also simply reduces workload by automating these tasks. Okay, the final feature I'll mention is AI-Enhanced Radio Resource Management, RRM. This is referring to Wi-Fi. It optimizes wireless network performance by dynamically adjusting radio settings on access points. And it uses AI to balance load among different APs, reduce interference through appropriate channel selection, and improve coverage by automatically adjusting the transmit power of each access point. Here's one small look at AI-Enhanced RRM. Here, we see statistics about channel utilization and interference. And down here, some more data about RRM. Notice here it states RRM changes that AI has made to optimize Wi-Fi performance in the LAN. Okay, that's all for our quick look at AI in Catalyst Center. Cisco has several products that incorporate AI in a variety of ways, but for the CCNA, you should just focus on the basics of AI and machine learning we covered in this video. Before moving on to the quiz, let's summarize what we covered. Artificial intelligence, AI, uses computers to simulate intelligence, capable of pattern recognition, learning, problem solving, and other tasks. Machine learning, ML, is a subset of AI that focuses on enabling computers to automatically learn from data and improve without the need for explicit programming. But like AI, ML is a wide field, and there are a variety of ways that a computer can learn. We covered 4. The first was supervised learning, in which the model is trained on labeled data to make predictions or classifications on new data. I used the example of training the AI on labeled photos of dogs and cats. Then there's unsupervised learning, in which the model is trained on unlabeled data to find patterns, relationships, or groupings in the data on its own, without a human labeling the data beforehand. In reinforcement learning, the model learns by interacting with an environment and receiving penalties or rewards based on its actions. Self-driving cars and game AIs are great applications of this. Finally, deep learning uses multi-layered neural networks, inspired by how the human brain works, to handle large datasets and perform complex tasks, more than is typically possible with other forms of machine learning. Okay, next we covered predictive and generative AI. Predictive AI uses machine learning to analyze historical data and predict future outcomes or trends. In networking, this can be applied to network traffic forecasting, threat detection, and predictive maintenance, to give a few examples. And generative AI uses machine learning to learn patterns from existing data and create new content, such as text and images. ChatGPT and other popular large language models are good examples of this. In networking, a few possible applications are configuration generation, troubleshooting, and script generation. This diagram shows the position of predictive and generative AI within the fields of deep learning, machine learning, and AI as a whole. Finally, I introduced a few AI-enabled features of Cisco Catalyst Center. The four I focused on were AI Network Analytics, the Machine Reasoning Engine, AI Endpoint Analytics, and AI-Enhanced Radio Resource Management. Okay, that's all we covered in the video. Now let's move on to a quick quiz to test your understanding. Here's quiz question 1. Which of the following types of ML imitates the human brain? Pause the video now to think about your answer. Okay, the answer is C, deep learning. Deep learning mimics the structure and functioning of the human brain by using artificial neural networks with multiple layers. These networks process information hierarchically, similar to how the brain processes data, enabling deep learning models to identify complex patterns and make predictions. Okay, let's go to the next question. Here's question 2. Which of the following Catalyst Center features leverages AI to perform a root cause analysis of network issues and propose resolutions? Pause the video now to think about your answer. Okay, the answer is C, MRE, which stands for Machine Reasoning Engine. MRE leverages AI to perform root cause analysis of network issues and propose resolutions. It can also take automated corrective actions to resolve issues without human intervention. Okay, next question. Here's question 3. Which of the following statements are true? Select 3. Pause the video now to think about your answers. Okay, the correct answers are A, D, and F. Reinforcement learning relies on a reward-penalty system to train models based on actions taken. It is particularly effective for game AIs, where agents learn strategies by maximizing rewards. Unsupervised learning uses unlabeled datasets to find patterns in data, unlike supervised learning, which requires labeled data. B is incorrect because supervised learning works with data that is already labeled and is not suited to discovering hidden patterns. Unsupervised learning is better for that. C is incorrect because, although the most powerful predictive and generative AIs use deep learning, it's not a strict requirement for a predictive or generative AI. And E is incorrect, as supervised and unsupervised learning can complement each other, and this is called semi-supervised learning. Okay, that's all for the quiz. And that's all for this video on AI and machine learning. While a fundamental understanding of the basics covered in this video should be enough for the CCNA exam, there's no doubt that AI's role in networking will only grow in the future. AI definitely has the potential to revolutionize network automation, so I'm looking forward to what the future brings. I hope this video was helpful. Thanks for watching. Before finishing this video, let me thank my JCNP level channel members who support me through YouTube channel membership. To become a member, please click the Join button under the video. Thanks to Jonathan Makura, George, Gustavo Macedo, Marcel Lord, Dragos Hirnea, Zakib Shah, Mayor Salman, Vitaus194, Mark Jackson, Bold1C1U, Gerald Guillaume, Hector Hernandez, Arpad Conives, 5 Feet, Owad Daniel Brown, Jose Alvarez, Hussein Yavuz, Samuel Tavares, Kevin Hayes, Roger Bratseth, Brian Grant, Georgi Gemejev, Addison Pereira, Madmark 50484, Alexandru Stratan, DMJ2, Steve Cox, Jasper Yim, Pedro Hartman, Tricky Mickey 123456, Ivano Capuano, Jefferson Steelflex, Toxic, Sinan Sarisinar, Wilmer Romero, Daniel Andrade, Dragos George, Philip Jovanovic, Trevor Goldman, Sunny Idigu, Hello BPDU, Edificare, Mikhail Chapsky, Hemanth Jabalpuri, Dariush D, Juan Morales, Gonzalo Nicolas, Doomed Soul, Julio Maya, Egreso, Hashem Rodef, Anand Abyankar, Clyde Mkorobindo, Orlando Flores, Adekola Ismail Salami, Adrian Martinez, MD Danielwitz, GG7, Ray Enriquez, Tobe Hedin, Vic, MDS Electronarzedja, G. Gant, Raymond Kirby, Henrietta Sauer, Yukshika, Uma Shankar Sharma, Ali Riza Belir, Seb Z, James Corley, Oleksiy Usov, Kit Kat, Excelius, Captain Flamingo, Tidiane Kone, To Be Like Our Superheroes, Mohammed Balta, Tazo Gurganadze, Opsero, Mohammed, Gideon Ibikunle, Matteo Falcone, Omole Celine, Genre Be Good, Zach Ross, I'm Me 87, Kumarasan JD, Kihinde Oniyide, and Johannes Boom. Sorry if I pronounced your name incorrectly, but thank you so much for your support. Thanks to you and my other supporters, I am able to make these videos and release them for free on YouTube, so I really appreciate the support. Another great way to support the channel is to like the video, leave a comment, subscribe, and most importantly, share this video with others. So if this video was helpful, I'd appreciate it if you did any of those. Thanks for watching.